Cisco Packet Tracer is a network emulator from Cisco system. It allows you to design and deploy different network topologies, from simple ones to more complex ones. In this video, I'm going to show you how to download Cisco Packet Tracer and install it on a Windows computer. I'm going to show you how to design and deploy a simple topology, and I'm going to walk you through the process of understanding how the packet travels throughout the network, as it is going to help you a lot during your studies. So let's get right into it. Okay, to download Cisco Packet Tracer, we have to go to the Skills for All with Cisco website. So that's the e-learning platform for Cisco associated with Cisco NetAcad. And we're going to choose the course Cisco Packet Tracer. So that's the way we're going to get to the link where we're going to download the application. So here in the top, we're going to click on Explore, and we're going to select the popular course Cisco Packet Tracer. Now, because I'm already assigned to this course, I'll have this presentation. So in your case, because that's going to be the first time, it's probably going to show in different ways. So you just have to start this course anyway. So I'm going to resume the course, and there is a lesson. So one of the lessons on the first module, that's the lesson 103. We're going to select download Cisco Packet Tracer, and there is a link that will direct me to the resources page where I'm going to download Cisco Packet Tracer. There are other resources on this page, as we're going to see in a minute. So we have Cisco Packet Tracer, we have a VM for cybersecurity training, and they have Kali Linux as well for cybersecurity training. In this case, Echo Hacker course. So we want to choose Cisco Packet Tracer, and we're going to install it on a Windows computer. So I'm going to select Packet Tracer for Windows 64 bits and just click it on it to download. Once you download Packet Tracer, we're just going to install it. So double click on it. Okay, so it's a very easy to follow process. So accept the license agreement, click on next, select the destination folder where it's going to be installed, and just install. Okay, the installation is completed, so now we're going to finish, and it's going to launch Cisco Packet Tracer. Now, would you like to run multi-user when application starts? So I'm going to click on no, because I don't plan to use it connected to the internet. Now, if your computer has internet access, it's going to prompt you to log into a Packet Tracer, but if you don't have internet access, you'll be able to use the application. So just to let you know about it. So I'm going to close this because I don't plan to use it. This is, oh man, shutting down. Okay, no problem. I'm just going to press OK, and we're going to open it again. It actually has to check that you don't have internet access, otherwise won't let you connect or open Packet Tracer. Okay, so we'll leave it for a couple of seconds because I don't have internet access. Okay, it appears, so it means that now we can use it offline. Okay, this is the workspace where we're going to design or deploy our network. And so let's start with a basic example. So let's set up a network with two computers. Okay, let's suppose we want to deploy two computers, one switch, one router, and a server. So you just want to simulate the internet access from a home network. Okay, so everything we want, we're just going to drag and drop and then make the connections. So for instance, we want computers, so we're going to end devices, and we're going to select the computer. So you can see that we have PC, we have a laptop, we have servers. I'm just going to select PC and a laptop, okay, because those are the type of devices that you can have at home. And we're going to also get a switch, so we select network devices. So we have a list of routers, but we want switch first, so I'm going to click on switch, and you can see that we have different types of switches. So we're going to select on 2960, just drag and drop it. Okay, we can see that it has 24 ports. So these models, they replicate the real devices. So now we're going to select a router, and let's select 2901. Okay, and that's it. So now I need one more switch and a server. So let's select a server, a Smerike server. Okay, let's just select the server. Okay, so those are the devices we're going to use. Now we have to interconnect them. So we're going to select here on connections, and we can either choose automatically the connection, so which means that Packet Tracer will automatically detect the type of connection to be used between the devices, or we can manually choose the type of cable or connector we want to use. For instance, let's suppose we want to use a straight cable. So between PC, we're going to select port FS Fast Ethernet 0, and then we're going to connect to Fast Ethernet 01. And on laptop, we're going to do the same thing. So we're going to click on Fast Ethernet 0, and here on 02. Now between the switch and the router, let's select the auto connection. We'll click on it, click on switch, and click on router. And we can see the connection was made between port gig 00 on the router and port 03. Now let's suppose that we did a connection, but we want to remove this connection. So in this case, we're going to click on del and just delete the cable. So to remove the option or the option select, so we're going to escape on the keyboard. So yes, C. So now we have the normal pointer. So now we're going to select the copper straight through, and I want to click on gig 01 interface and click on port gig 01 also on the router. Now we saw that between the computers and the switch, the ports, they were green and were kind of orange or amber. So it means that they were negotiating the ports, but we can see that between the switch and the router, it's actually red. Well, the switches by default, they have all the ports enabled, but the routers, they have all the ports disabled by default. So which means we have to enable the ports on the router. So we're going to let's just enable the port. So we're going to click on the router, and this is like the front and the rear image of the router. So we're going to click on config, and we're going to choose the port 00. So we can see that we have global configuration, but we want to go to interface, in this case 01, and we're going to click on to enable the port, and we can see that now the color changed to green and it's amber on the switch side. Now it might be hard to identify which port we are actually trying to make the change, because we can see from here. So if we want to display the port, I'm going to close this, and here on options, preference, we're going to select the option always show port labels. Okay, going to enable that, and you can see that now we can see all the ports labels. Now let's continue the connection between the router and the other switch. And if I want to use the cable multiple times, I just click on, let's see, shift and the cable. So now I'm going to click on the router and use gig 0 and click on switch, and I want to use gig 01. So actually it has to be control. So now it's the last one, so it won't make any difference. So I'm just going to connect between Fast Ethernet 01 and Fast Ethernet 0 on the server. Now again, the port is red because gig 00 is shut down on the router side. So we're going to enable that port 00, and we're going to change the port status to on. Okay, we have all the ports connected. Okay, but now in network, the devices, they communicate using IP address. So what's the IP address we're going to use in this example? So we can write the planning for this network. So if we select, let's see, I believe that's text, place a note, yes. And let's suppose we want to use the network address 192.168.1.0 for LAN. So 192.168.1.0. We're going to use the mask 255.255.0. And between the router and the server, we're going to use the network. So we're going to represent this as a public network. So I'm going to use the address 19.168.1.0 with the mask 24 as well. Okay, so I'm going to click on escape, and I can drag and drop now this node. Okay, so we're going to set the first IP address on the router and the remaining IPs to the other devices, which means the router we have 192.168.1.1, PC0 we have 1.2, the laptop will be 1.3, and between the router and the server, the router we have 19.168.1.0 and the server will be 19.168.1.2. Okay, so let's start with the router and let's go to gig01. Let's set the IPv4 address 192.168.1.1 and the mask, it will automatically change to the corresponding for this class. Now you might notice that we have here this display saying the equivalent iOS commands, which means that we can either configure using this option or using the CLI like we would do on a real device. So if we want to change to CLI, we can click here on this tab, and now we're going to configure the router using the CLI options. So let's actually configure port G00 using the CLI. So going to G00, so there is a typo there, interface G00, IP address 19.168.1.1, okay, and I'm going to enable the port, okay. And one thing that I can also use to prevent typos is say no IP domain lookup, so the router won't try to resolve a name to an IP address. And let's actually change the router name to, let's suppose, RT1901, okay? And we're going to save the change, okay? Just like we would do on a real device. Okay, so let's change the IP address on PC as well. I'm going to close the router. I'm going to bring PC0, so you can see it looks like a real device, a real computer. A desktop one, so we can either configure the PC using the config tab or the desktop tab. So for PC we're going to use the config tab, and the laptop we're going to use the desktop tab. So the interface we want to assign the IP is fastnet 0. We're going to use IP configuration static. Okay, so I'm going to type the IP 12 and the mask is /24. Okay, we're going to close this one. Now the laptop, so again it looks like a real laptop, so we go to desktop, IP configuration, and here we're going to type the IP address, so 192.168.1.3 and the mask. Okay, now we're going to close this, and now the server, let's change it, config. We can use config or desktop, so we're just going to use desktop, and the IP is going to be 19.168.1.2, and we're going to change the mask to /24 to be the same as the router. And okay, let's close this. Okay, so far everything looks okay. We configure the IP address for those devices. Now how do we test, how do we validate if everything is actually working? Now before testing anything, I want to bring your attention to this. So Packet Tracer has two modes of operations. So we have real time and we have simulation. Real time, it means that whatever we test and service, any application that we test, the test is going to happen in real time. As for simulation, we'll be actually able to see how the packet will traverse between the devices. So first we're going to use the real time, and then I'm going to show you the example using the simulation. So for instance, let's go to PC 0, desktop, let's select command prompt, and I'm going to type ping 192.168.1.1. So you can see I got reply from the router, so it's working. But how do we know, how the router is able to know about this? Which path did the packet took to reach the router? So what happened? Okay, simulation will allow us to understand how did it happen. So I'm going to change to simulation, and here are the different protocols that we can see, but I'm going to clear all of those, and let's just select the ARP, and let's see, do we have ICMP? Yes, we have ICMP. What else? CDP, DTP. Okay, I believe let's just look at ARP and ICMP. Okay, we're going to close this, and let's send now a ping from laptop. So ping 192.168.1.1. Okay, and now I'm going to press enter. So this is the first packet that the laptop is sending, and look at this, we can see how the packet will arrive at the router, if it's going to arrive at the router. So we're going to click on play, or we can forward the simulation. So let's first forward. So the first packet is sent, and I'm going to expand this a little bit. Okay, so we can see that it was sent from laptop to switch. Okay, going to continue. So the switch receives the packet, and normally when the switch needs to know, okay, to whom I'm going to send this packet, so the switch is going to float to all of its ports. So let me show you if I can get more information about this. If we double click on this, so it's going to show us, actually let's go back, let's see. So you can see all the explanation, all the steps happening kind of real time, but this is a simulation. So we see that, let's see, this is from source, the laptop. So the frame destination MAC address match the receiving port's MAC address. The device decapsulates. So this is actually the switch already knows. So let's open this one. When the switch floats all of its ports. Okay, so it receives the frame, match the receiving, the broadcast, the device, the ARP frame is request. Okay, the ARP request target does not match the receiving port. So this is from, so this is a broadcast. Okay, so the packet source is 1.3, destination. So okay, the laptop is trying to know where is the MAC address for this IP 192.168.1.1. So if we move forward to the next layer, so let's continue. So now it's actually here. Okay, I'm clicking too fast. Okay, so let's see step by step. So now the MAC address arrives. Okay, so the frame source MAC address was found in the MAC table of switch, which means router is replying with its own MAC address on gig 01. Okay, now let's see, the outgoing port is an access, switch port sends the frame, so switch is sending now the reply to laptop, because now it knows the MAC address of the router and is replying to the port where it received the request. So now the laptop is going to receive this packet, okay, and it will see the MAC address associated with the IP 192.168.1.1. That's the router's IP address. So let's continue. So now laptop is going to send another packet directly to the router. So it's going to send to the switch. The switch already knows the MAC address of the router, so it's going to forward directly to the router. So once the router receives, it's going to reply and saying, okay, this is an ICMP response, so everything is okay. So now if we bring the laptop, we should see that the first packet was successful. So the laptop is going to do this process twice, because actually 4 times, because there are 4 packets. So let's just press on play and see this happening. Okay, and let me bring laptop. Is it continue? Yes, now it's going to do it automatically. So now it's going to do the same process. So now the switch is going to send to the router. The router is going to reply to the ICMP packet. Okay, that was the second packet. So there are 2 more to go. Now this is very useful in case we need to understand how the packets flows in the network. I used these in situations where I needed to troubleshoot an ACL problem, to understand how the R process was happening between switches. So different use case, it's actually great to use packet tracers instead of other more advanced tools. So because you can have like a big picture of the network, but inch by inch. So it's very helpful. So that was the third packet. So that's going to be the last one. So then the ICMP packet will be successful. And you can see 4 packets sent, 4 packets received, and it was successful. So we can change these to real time. So that's how we can use the simulation tool to understand how the packet flows in the network. Now let's try another example. And this time we want to send an ICMP packet from the PCs to the server. Now let's do this. Now I could also use the terminal to send the packet, or I could use simulation and choose the PDU. So it should be here. Place node, no. So there should be, I believe it's here, add complex, add simple PDU. Yes, should be a simple PDU, and I'm going to send from PC to the server. Okay, I'm going to press play, so I only have ARP and ICMP. Okay, now let's see what's going to be the message. So it looks like there was a problem. So let's click on it. Okay, double click. Okay, so what did it say? So the ping process starts the ping request. The ping creates an ICMP echo request and sends it to the lobby process. The source IP, so the buffer is full. So I'm going to drag you over here. Now the source IP address is not specified. The device says it's to the port's IP address. The device sets TTL in the packet header. The destination IP address is not on the same subnet and is not the broadcast address. The default gateway is not set. This device drops the packet. So you can see it's very helpful and gives you a lot of details on why things are not working. So the problem is that first, the server is not in the same subnet as PC0, and we don't have the default gateway set on this PC as well. So that's the problem. Okay, let's stop this for now. Clear event. Okay, and let's just go to real time, and I want to change this. So we're going to set the default gateway on PC0. So we're going to set to the router IP address 192.168.1.1. We're going to close this, and also on the server I'm going to set the default gateway to be the router 192.168.1.1. Okay, I believe that now it should work. I want to clear this, back to simulation. Let's send our PDU again and press on play. So we can see the packet is leaving the switch or the PC. So then we have flooding because the switch doesn't know the MAC address assigned to that IP address. And the router replied, okay. And it's going to reply. So what's going to be the output? Okay, so it looks like the router can handle the packet. Okay, so that's great. And so now the switch forwards to the router. Okay, and the router is going to send to the switch. Okay, so it's going to be delivered to the server. That's okay. The server receives the packet. Okay, that's great. So far so good. The server replies the packet is delivered to the router, and now it's thinking. It's taking too long. Let's just give a couple of seconds. Okay, it looks like it's not working. Okay, let's see if we have the reason why it's not working. So the buffer is full. Okay, so let's see what seems to be the problem. Okay, let's see. The frame destination match the receiving port. The device ARP. Okay, from router to switch, this looks okay. Was found. This is a unicast. Okay. Is a switch sense. Okay, that looks like it's related to that X. Well, but the problem is that those devices, they are in different networks, and the server doesn't know about this network behind the router, and the PC doesn't also know about the network where the server is. So the way to solve this problem is either to install the routes directly on these devices, or to actually use NAT or network address translation on the router. So that's what we should use in first place, actually. So let's go into the router configuration. Actually, I want to change first to real time, and let's go to CLI. Okay, and let's create let's enable NAT. So for that, I'm going to use first an access list 1, permit any IP not inside source list 1 interface G00. So I'm going to create a path port address translation. I want to hide all the IP address on 192.168.1.0 to be advertised on the server as being the router's external IP address. Now on my G00 is going to be my outside interface, and my G01 is going to be my inside interface. So if I type now do show IP NAT translation, so I don't have any translation happening, but I'm going to delete this test. Now if I send the PDU again, let's go to simulation. I'm going to grab this and send another packet and press play. Okay, so now PC sends to switch is going to forward to the router. The router is going to reply back. No, it doesn't have to, because it already has this information in its routing table. So forwards to the switch is going to forward to the server is going to reply back, and that should be delivered, and the switch is going to forward to the router is going to send back to the switch, and the switch is going to deliver to PC0. And if we look at PC0, so I'm going to close this. Can I see this? No, I can't. Okay. can only monitor it using the simulation. Okay, so we can see that the last status was successful. So the ICMP packet was delivered from PC0. So I'm going to clear all of these and go to real time. And if we send an ICMP packet now from PC0 to 19.168.12, we should get reply from the server. Okay, so this is a very simple and basic topology, but just to show you that how easy but helpful Packet Tracer can be. And if we want to make this more complex, we can do so. For instance, if we want to add more routers, let's select a couple of routers here, so 19.1.1. So we can add multiple routers and make it as complex as we want. So let's delete these. For instance, actually I can delete these. Okay, let's suppose we want to make these, okay, a group of the routers connected in a service provider environment. Okay, so I can delete this. Yes. Okay, and just going to click on connector. So probably I won't have enough connectors. So click on this one, click on this one, so click on this one, click on this one, and now the routers, they only have 2 gig ports. So if I want to increase the number of ports, so I can select one of these cards. So let's see, this is switch port. There's a gig E port, but that's SFP, so we want Ethernet. So that's, let's see, that's the serial port, no, and that's a switch port, that's not, so that's asynchronous, just as a cover, so that's SFP. So I believe that the best one should be the Ethernet port. Okay, so in this case we would have to, okay, so we have to power off actually first. So what is the, yes, so we can power off and only then plug the module and then power back on again. But actually let's just delete these ports and use these connectors. So I'm going to use auto between these two and between the server. Okay, and we can also, I'm going to show you in a moment, so we can also configure more advanced topologies. For instance, let's suppose we want to configure BGP between these two routers. No, I don't know, so that's router 3. Okay, so between 00 no shot IP address, so I'm using the address 19.168.1.2.555. okay, let's suppose I'm using BGP 3 and my neighbors 192 actually is 19.168.1.1. remote AS is, I suppose it's 1. Okay, and let's see if we can enable BGP between these two routers. So let's put it side to side, router 3. Router BGP 1, and my neighbor is 19.168.1.2. the remote AS is, which one I use 4. And we can see that BGP session is already up. And if I advertise my local network, mass 255.255.255, that should be advertised here on this router. So show IP, let's see, show BGP IPv4. Okay, show BGP. Okay, show IP BGP. But that's the problem with an emulator. Not all commands are supported. But we can see that our 2901 network was advertised to router 4, or in this case router 3. As you can see, with Packet Tracer we can deploy not only simple topologies, but we can deploy the complex ones as well. It all depends on your progress, on how comfortable you feel with the technologies that you'll be studying or training, so then you can move on to real simulators, or simulators that allow you to replicate what you might actually find on real device, just like Cisco CML, even GNS3, or even PNet. And we're going to cover this in the following videos. So I hope you found this video useful, and I hope to see you in the next one. Adios!